Hello, welcome to another episode of Understanding AI. So in this episode we move on to another term that forms part of GPT, Generative Pre-Training Transformer, and we're going to be looking at the term transformer. And I'll be doing that once again in a fairly broad way, mainly talking about it in terms of conceptually what it means, but as always I'll be including some links in the description which should point you in the direction of a few papers that you can read, and in those papers you'll find some quite nice diagrams which show the structure of a transformer and also diagrammatically explain other concepts that help you understand transformers, and also an important concept within them, attention. So let's start looking at some of these concepts. So first up, let's look at the term generally transformer. So in the context we're talking about, a transformer is a deep learning model that adopts the mechanism of self-attention, differentially weighing the significance of each part of the input data. Transformers learn context and track relationships in sequential data, such as words in a sentence. The transformer is a component used in many neural network designs for processing sequential data, such as natural language text. A key part of the transformer is the attention mechanism. Now, in deep learning models, just to clarify what a deep learning model is. So a deep learning model is a type of neural network that can have many layers of units. Each layer can perform a different function on the data, such as filtering, combining, transforming, or extracting features. So here I'm talking very generally. The more layers a model has, the more complex and abstract patterns it can learn from the data. Now, attention specifically, so put simply, the attention mechanism is a way for neural networks to focus on specific parts of an input sequence when processing it. It does this by assigning weights to different parts of the input sequence based on their relevance to the task in hand. In practice, attention is used in three different ways in a transformer. We have encoder-decoder attention, self-attention in the encoder, and self-attention in the decoder. And I'll come on to explain this in a moment. But firstly, I just want to talk about the focus of attention, how it decides what to focus on. So the focus of attention is decided by computing a set of attention weights that indicate how much each input element contributes to the output at each time step. I'll explain time step in a moment. These weights are computed based on a similarity measure between the current decoder state and each encoder state. The attention weights are then used to compute a weighted sum of the encoder states, which is used as input to the decoder at each time step. A time step is the sequence of words that are fed into the model at each step during training. Encoders and decoders. So an encoder in deep learning is a neural network that takes a variable length input, such as a sentence, and transforms it into a fixed length output, such as a vector. The purpose of an encoder is to extract the most important features or information from the input and reduce them to a smaller representation. An encoder is often paired with another neural network called a decoder, which takes the output of the encoder and generates a new variable length output, such as a sentence. They form an encoder-decoder architecture which can handle different types of sequence-to-sequence problems. Now, on to self-attention. So a technique that allows a neural network to learn how to pay attention to different parts of a sequence, such as words in a sentence. It compares each element of the sequence with every other element and assigns a score that indicates how relevant or related they are. These scores are used to weigh the elements and produce a new representation of the sequence that captures the most important information. Self-attention can help the neural network to capture long-range dependencies, contextual information, and semantic relationships within the sequence, as well as improve the efficiency and parallelization, of computation. Now, another term you might come across is multi-head attention. So multi-head attention is a technique that applies an attention mechanism multiple times with different parameters and combines the results. This way, the neural network learns different aspects or perspectives of the input data by using different representations. It can help the neural network to capture more complex and diverse patterns, improve the expressiveness and generalization ability of the model, and reduce the redundancy of the attention outputs. It is often used in conjunction with self-attention, and they form a key component of the transformer architecture. Now, on to those 3 papers that I recommend checking out, and I'll include links in the description. So we have one from 2015, a neural machine translation by jointly learning to align and translate. Attention is All You Need from 2017, and that contains a really nice diagram of a transformer model. And thirdly, an older paper which I see recommended an awful lot when thinking generally about deep neural networks, and that's the paper ImageNet Classification with Deep Convolutional Neural Networks. I often see that recommended as a good starting point for getting your head around deep neural networks. Thanks once again for watching. Bye for now, and I will catch you in the next video.